Okay, so let's look at another example here. So this one is genetics. Suppose a married man and woman both carry a gene for cystic fibrosis, but don't have the disease themselves. According to the laws of genetics, the probability that their first child will develop cystic fibrosis is 0.25. This is our Punnett square stuff. Remember that with your Punnett squares when you draw your box and you divide it and you put the parents on the side and you figure out what the probability of the kids. So explain what this probability means. So again, in context, right? So all this probability means that when this couple, if I have a couple that had cystic fibrosis and both have the disease, then about 25% of those children will have the disease. And again, if you look in the answer there, it says if we had many couples, okay, remember, so back to that idea of long run. I have to have a lot of couples that both of them have cystic fibrosis. Well, they have the cystic fibrosis gene would be a better way to say that. Okay, so both have the cystic fibrosis gene, but they don't have the disease. Tested their first child, about 25% of the children will have it. If the couple has 4 children, is one of them guaranteed to get cystic fibrosis? No. This goes back to the fact that these are independent events. Each child has a 25. That Punnett square starts over. So each child would have a 25% chance of getting the disease. Okay, let's look here. Free throws. The figure below shows the results of a virtual basketball player shooting several free throws. Explain what this graph says about the chance behavior in the short run and in the long run. So the short run probability here, okay, I've got a lot of variability. Okay, here's my shots going across the bottom, right? I'm going from 1 to 100. Okay, in the short run, divided by 10 is 10. These are not quite 10s. Okay, so about 10 to 20 shots. Okay, I'm going down. You know, my likelihood was that, so on my very first shot, my likelihood is 50-50, right? Okay, I'm either going to make it in or I'm not. Okay, and so as they take some shots, okay, in the short run, it looks like they never make one. You know, they're just not hitting it, not getting it, not getting it, not getting it, not getting it. Okay, and their probability is super, super low. A lot of variability there. But in the long run, as they take more and more shots, we start to see this pattern. And so now, based off of this particular player, you could say that they make about 30% of their free throws.